All right, guys. So that was part one. We got 1 through 20 done. Let's keep going on. So we're now in 21. Graph the linear equality on the number line and write the answer in interval notation. Once again, all these topics we've gone over in class. You just got to review them if you don't remember. Let's go ahead. So to graph a linear equality, we have to get x by itself. Typically on the left side is much easier. So I'm going to go ahead and subtract the 6x on both sides. Cancel those out, zeros out, bring down the x minus 4 is greater than negative 5. Add 4 on both sides to get us that x by itself, right? So then we get x is greater than negative 1. This is going to be the solution for the inequality. So next things first is we draw our number line, right? A horizontal line. And then 0 in the middle, negative 1 on the right, negative 2, positive 1, positive 2. And since it's a greater than, it's going to be an open circle and a parentheses. So it's going to be open circle and negative 1. So it wants greater than. Greater than is to the right. So because these are numbers are all greater than. Draw the arrow there too. So that's the graph. Now the answer interval notation will be parentheses because it's open. Negative 1 to positive infinity. And we are done. This is the answer for number 21. Let's go ahead and move on. Number 22, graph the linear equality on the number line and write the answer in interval notation. Same concept as before, but we have more steps to do now. So here we have like terms. 9x minus 6x is 3x, right? So bring down this over here, minus 6. I'm going to subtract 3x on both sides. This zeroes out, so this is 0. Bring down x minus 6. I'm going to add 6 on both sides. And I'm going to get x is less than or equal to positive 6. So here it's going to be a closed circle and it's going to be a bracket. And I put this way the bracket because it's going to go to the right side. Ignore that, my bad. So now let's go ahead and keep going. So make a number line, right? And we're going from positive 6, right? So on this one, I'm going to go ahead and put like 0 more to the left here because I can do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's going to be a closed circle at 6, but it's less than, right? And 5 is less than 4, 3, 2, 1, 0, negative numbers, so it goes to the left here. So that's the graph of that. Now we're going to go ahead and do a parentheses, right, because it stops here. Remember, because our interval goes from left to right, so this arrow goes to negative infinity, parentheses, right, comma, and it stops at 6 with the bracket because it's including the point. And right here, this is our solution. Now I've noticed some textbooks use like a bracket here too, like instead of a close point, they put a bracket here, but do a close point, guys. And if you want to put a bracket with it, you can. And over here, you can include the parentheses here, but don't go through the open circle. So that way you know, but there's no right or wrong way. So let's keep going. Number 23. Find the x and y coordinates of point E. Type in ordered pair. So from there, guys, we're going to go ahead and look at the point E. You see how the x value is right here at negative 4. And then we're going to go ahead to the right for the y value, which is between negative 2 and negative 4, which is negative 3. So the ordered pair would be parentheses negative 4 comma negative 3 for y. And we're done. Knowing which numbers are what, the quadrants, remember, it's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We don't need it for this one, but you need to at least remember these facts here because it's going to move forward. Now, number 24, it's kind of a loaded question, but bear with me. Determine whether each ordered pair is a solution of the given linear equation. So we have 3 ordered pairs, and we want to check if they're a solution of this equation here. So let's look at the first one, 6, 1, x and y. So we're going to plug. We have the formula here, 2x plus 5y equals 17. We're going to plug these in for x and y. So it'll be 2 parentheses 6 for x plus 5 parentheses 1 for y equals 17 question mark. We don't know if these are solutions, so let's go ahead and find out how. 2 times 6 is 12. 5 times 1 is 5 equals 17. 12 plus 5 is 17 equals 17, which is a true statement, which is what? It's a solution. So we stop here. Now for B, that's going to be negative 4, 0, so that'll be x and y. So plug it into the formula, it'll be 2 parentheses negative 4 plus 5 parentheses 0 equals 17 question mark. 2 times negative 4 is negative 8, 5 times 0 is 0. So we get negative 8 equals 17, which is false. So this is not a solution here. And then last but not least, we have this one here. So it'll be x and y here. So it'll be 2 times 0 plus 5 times 3 equals 17 question mark. 0 plus 15 equals 17. 15 equals 17 is false. So therefore this is also not a solution. And this is how you find if ordered pairs are solutions of a linear equation. And pretty much a solution means this 0.61 is part of the line. These other points are not going to ever cross the line at all. So that's why it's a false, not a solution. Alright, let's keep going. 25, we want to graph the linear equations. I showed you multiple ways to graph here. We graph by using the line, we graph by using a table, we graph by using points, we graph by using equations. So this one we're going to use equations, because this is actually y equals mx plus b, where m is the slope, which is rise over run, and then the b is the y-intercept, where it crosses the y-axis, 0, comma b. So right here, let's use that formula now, right? So m is equal to 3 over 2. So we're going to rise 3, run 2. And then the slope, the y-intercept is 0, comma 3. So we have information we need to graph this line. So let's go ahead and draw our axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. So we know the y-intercept is 0, 3. 0, 3 is right here. And we know the slope is rise 3 over 1, right? So I'm going to add another line here. So we're going to rise 3. 1, 2, 3. And we're going to run 2. 1, 2. Voila. And then draw your line. And we're done with graphing. 26. Graph the linear equation. You can either solve for y, get y by itself, so you can get the y equals mx plus b, right? You can do that route. So you'll subtract 3x, divide by negative 1, and then divide, and then plug in your points. For me, what I'm going to do is I'm going to use a x and y intercept rule. So we know the x-intercept is x comma 0. So I'm going to plug in 0 for y and solve for x. So I get 3x minus 0 equals 9. And then I get 3x equals 9 divided by 3. And I get x equals 3. So the y-intercept is 3 comma 0. I'm going to graph that bad boy. And I'm going to need the y-intercept too. The y-intercept is in the shape of 0, y. We're going to plug in 0 for x. It'll be 3, 0 minus y equals 9. 3, 0 cancels out, right? 3 times 0 is 0. So I get negative y equals 9. Which is a negative 1, divide by that, and then we get y equals negative 9. So the order pair is 0, negative 9. So we have what we need to graph the 2 points, and then we're just going to connect those two. I'm just showing you the different ways you can make a table, or different ways you can graph a line. So then we're going to go all the way to negative 9. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the x-intercept is positive 3, 1, 2, 3, 4, 5, 6. So positive 3 is right here. 1, 2, 3. That's the x-intercept. The y-intercept is right there. And just get your ruler and connect them. On my math lab or on the paper, you'll create your own graph like this. Make sure the points are correct and the line is correct. Alright, let's keep going. Another graphing the linear equation. So I showed you solving for y or using the x-intercept, y-intercept formula. This one I'm going to show you by solving for y, right? Because you can manipulate equations because you know how. So I'm going to subtract x on both sides. So I get negative y equals negative x plus 3. right? Negative x, 3 is positive, so it's plus. And there's a negative 1 here, so divide by negative 1. The 1's cancel out. Negative, negative make a positive x. 3 divided by negative 1 is a negative 3. This is much easier to graph, right? We know m is in front of x, which is 1, right? So m is equal to 1, and then the b is equal to negative 3, which is 0, negative 3 as an ordered pair. So now we know the m and the b, so we're going to use those facts to make a graph. Don't overthink these at all. So we're going to go down to 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So 0, negative 3. 1, 2, 3. And slope rise 1. So this is a 1, right? So make it to a fraction over 1. So it's rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. And then once you get enough points, get your ruler and make your straight line. Don't forget your arrows. And we're done. Alright. So far, so good, guys. Let's keep going. So find the slope of the line that goes through the given points 10, 5, and 9, and 10. So for this one, we're going to have to utilize the formula for slope, which is m equals y2 minus y1 over x2 minus x1. So to do that, we need to label these points accordingly. So this is x1, y1, x2, y2. We can actually go vice versa if we wanted to, as long as we're consistent with x1, y1, and then x2 with x2. So keep going. So y2 is 10 minus y1, which is 5, over x2, which is 9, minus x1, which is 10. 10 minus 5 is 5. 9 minus 10 is negative 1. 5 divided by negative 1 is negative 5. So m equals negative 5. That's the slope. Find the slope and the y-intercept of this line. So this is going to be a perfect example of solving for y. Solve for y, because that's what we got to do, right? So when we solve for y, we're going to get y equals mx plus b, which will tell us the slope and the y-intercept, right, for m and b. So let's go ahead and subtract 5x on both sides. So now I get negative 9y equals negative 5x plus 45. I'm going to divide both sides by negative 9. This side has 2 terms, so I'm going to put negative 9 twice. This becomes 1, right? 1y, or y. 2 negatives make a positive 5/9, right? Negative, negative. 45 divided by negative 9 is negative 5. And we're done. These 2 points are the m and the b. So the slope is m equals 5 over 9. And then the y-intercept is b equals negative 5, or 0, negative 5. And we're done. Let's keep going. Number 30. Determine whether the parallel lines are parallel or perpendicular or neither. Now to do that, guys, we don't want to overthink these things. So now remember, to be parallel lines, it needs to be same slope. So exactly the same number. Perpendicular, they have to be opposite reciprocals. So like if it's one positive and negative, and then the flip version of each other. So luckily we know m here, the slope for L2 is 7. So we need to go ahead and get the first equation, x minus 9y equals negative 3. We got to get y by itself, right? So we're going to go ahead and subtract x on both sides, because we want to compare what the m is, right? So we get negative 9y equals negative x minus 3. Divide both sides by negative 9. So then I get y equals 1 over 9x, right? Because this is a divisible 1. 2 negatives make a positive. And then it'll be 3/9, so it'll be positive, negative, negative. 3/9 is just 1/3 row, right? Because we're dividing this by 3 and this by 3, which is 1 and 3. So now the slope here is 1/9. Now are they the same? Nope. Are they opposites? They're both positive, so they're not opposites. So guess what? These lines, so the pair of lines are neither. They're neither parallel or perpendicular. All right. 31 wants us to graph this equation. So we're going to go ahead and follow the m and b thing, right? So we know m is equal to -5, right? It's not a fraction, so over 1. Since it's negative, so when it's positive, we rise over run. But when it's negative, we fall 5, and then we run 1. Remember, we always run to the right, all right? Always run to the right. It's when it's negative, we go down. Always run to right. All right, and then we know the b is 3, which is 0, 3. So we have what we need to graph our equation. So it'll be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So let's go ahead and go. So the b is 0, 3, 1, 2, 3. And he falls 5. So 1, 2, 3, 4, 5. Run 1. Go down 5 again. 1, 2, 3, 4, 5, 1. So you follow the same slope more than once if you want to get like more points to connect. You only need 2 though. Only need 2 to graph a line. All right, guys. Only need 2. Let's go ahead and keep going. Number 32. Find an equation of the line with the given slope that passes through the given point. Ooh, this is a juicy one. So we want to find the equation of a line, and with the given slope passes through the point. They want us to write it in this form here, and they're giving us the m and the point. So this is a point x1, y1, right? And this is m. So the formula we're going to have to use is the point slope formula, which is y minus y1 equals m parentheses x minus x1. Then we're going to plug in these 3 points here, which is what we have over here. So then we get y minus -2 equals -1 parentheses x minus -9. 2 negatives make a positive. Don't forget that. Now we're going to go ahead and distribute this -1. So then we get -x minus 9, y plus 2. Subtract 2 on both sides. So then we get y equals -x minus 11. And guess what? Y equals mx plus b. It's in that form here. Y by itself. And we're done. When you don't know what's going on in the problem, you want to reread the problem and look at what they give you and see what you need to figure out, guys. Okay? Very important that you guys figure that out. Let's keep going. Number 33, simplify the expression. Interesting. So we have a fraction with a exponent here. So when you have a fraction with exponent, the exponent goes to the top and the bottom. So it'll become parentheses 4x to the 4th, parentheses 5 over parentheses 8y to the 5th power. Now we have a parentheses with an exponent. So what does that exponent do? It goes to every different thing inside the parentheses, like x and then 4, 8 and then y. So then we get 4 to the 5th power. And then we get x to the 4th to the 5th power. And the same thing here, we get 8 to the 5th power. And then we get y to the 5th to the 5th power. This is a power to a power, so we're going to multiply these exponents. That's a power rule right there. This is just 4 to the 5th power, so that's just 4 times 4 times 4, 5 times. So let me do that. Ooh, that's going to be an ugly fraction. So 4 times 4 times 4 times 4 times 4. 5 times 4. 4 times 4 times 4 is 3 times 4 is 4 times 4 is 5. That's 1,024. So we get 1,024 x to the 20th because we multiply 4 and 5. Then we get 8. 8 times 8 times 8 times 8 times 8. So that's 32,000. 768. And then times y to the 25th, right? Well, these are pretty big numbers, so we have to simplify this fraction, right, guys? So I know these are even, but divided by 2 would take too long. So I'm going to go ahead. Since 4 divides into 8, I'm going to assume this can be divided by this. So I'm going to divide both the top and bottom, guys. So it's gonna be, I'm going to do 1,024. I'm going to do 1,024 divided by 1,024. Then I'm going to do 32,768 divided by 1,024. Well, the 1,024 divided by, that's just 1. Here, this actually, look at it in the calculator, it becomes 32. So now that we know what we're dividing by, this becomes just 1x to the 20th over 32y to the 25th. And we're done. Now, another thing we could have done, guys, before we've done this step, guess what? 4 over 8 is just 1/2. This is the same thing. 1x to the 4th over 2y to the 5th, right? To the 5th power. So 1/2. I could have done that too. It's simplified this fraction first, and then do the power, and it would have been much easier. We would have skipped this step. But it's more, like I said, this shows kind of that math is very flexible. You can do more than one thing to take care of business. Let's keep going. Number 34, simplify the expression 4u squared over 8v cubed to the 6th power. So I'm going to do that step I told you earlier. I'm going to simplify 4 over 8. So we know that's just going to become 1u squared over 2v cubed. So this is a u, this is a v to the 6th power. So then we use the power, that quotient rule, right, with the exponent. So then we get 1 to the 6th power times u squared to the 6th power over 2 to the 6th power v cubed to the 6th power. Well, we know that's just going to be a power rule, right? So we're just going to be multiplying those two. And then here, 1 to the 6. 1 to the 6 is 1 times 1 times 1 times 1, which is just pretty much 1. U squared times 6, 2 times 6 is u to the 12th power. Over 2 to the 6 is 64. And then 3 times 6 is 18. Since they're different variables, we can't simplify, so we're done there. Now, we don't have to include the 1, right? We don't, but we could. It wouldn't change much about it, okay? All right, let's go ahead and move on to the next one, guys. Number 35, we want to subtract these polynomials, right? So before we subtract, the rule of thumb is we want to distribute that -1, right? When we multiply by -1, the signs flip. Negative 6y becomes 6y, plus 9 becomes -9. Now bring down the first polynomial, and now we combine like terms. 8y with 6y, -6 with -9. So bring down the 9y squared. 8 plus 6 is 14y. -6, -9 is -15. And there's no more like terms, so we are done. Alright, I'm going to go ahead and stop here, guys, and then we're going to do one last part, right? Part 3.